Hi, and welcome to this short series about adding multiplayer to a basic snake game. Today is part one. We are going to start by adding the basic functionality and go over what's included in the project. So to follow along, you need the following files. You can download them from gamedesign.se/snakebase2. I made a new version for you guys who used the first one. Remember capital S, capital B. It will it's not a page, it will just start downloading the file. Most of the information, if you want to dive deeper, I recommend looking at the simple guide at Unity's webpage. Just go learn tutorials and then scroll down to networking and or use this full link to go straight away. It's basically everything in this video is covered there. So if you want to dive deeper, that's the place. If you download the zip file, unzip it. It's a folder with the Unity project. Just open it with Unity. And this is basically what you get. So we have a main camera. I have changed the size here quite a bit because I want the Unity units to be quite small visually. We have an apple spawner that spawns apples. We have the 4 walls, and we have a snake that can move and eat apples. So if we hit play, we can see how it works. So I can start moving, and when I pick up an apple, the apples disappear and I grow a bit longer. And I can die. So that's the start of the project. So the goal of this video series is the goal of this episode is to have up to 4 players moving around eating apples and synced over the network. In part 2 and maybe part 3, we will add basic chat functionality. We will have the selection of player name and also a synchronous start, because now you can, when a player starts moving. So yeah. And also some basic stuff like who wins and so on. So the assets included in this project are the following. We have an art folder that contains one 32 by 32 image that's pure white. That's all the art we need for this one. We have some prefabs. We have the apples, the snake, and the snake body part. So the head is separate from the rest of the snake because there's 2 different behaviors going on. And we just have the one scene right now. And we have 5 different scripts that we're gonna take a look at. Let's start with the apple spawner. And we have a number of apples. I actually have a higher number set in Unity, that's why it's more apples. We have the prefab, and we have the size of the playing fields. And this is basically within what area the apples will spawn. We also have some to-do comments with difficulty settings. So the goal of this assignment for my students is that they can improve by following the instruction in the to-do comments and refactor the code and make it better. When we start our game, we will spawn apples every 5 seconds, and when we spawn apples, we will see how many apples there are by having the max apples minus how many apples there are right now. So get current amount of apples, just looks for how many apples we have in the scene by searching for the tag apple, and then returning that number into this calculation. And so say we have max 100 apples, we find 90 apples in the scene, well, then the loop runs 10 times, so we spawn 10 new apples. And apples just spawn at a random position between minus x and positive x, so 80 here means that we can go from minus 80 to plus 80 in the x-axis. And right now the apples can spawn on top of each other, so we can have stacks of apples, but who cares? It's not really important. So that's the apple spawner. Let's take a look at the other scripts. We have a snake script. That's the main script for the snake. it contains the time step, how often the snake should move. This means it's 10 times a second. How long the snake is. We then create a holder for the snake. We create an object that's the snake's parent because we want to put the body parts in the same holder. We have a color that we're going to use later for networking differentiation between different players. So the first thing we do in Awake is that we create a new game object and save that transform into body holder, and then say that that is our parent. And we set the color depending on the sprite renderer. So let's look in Unity. Our snake, you see it's here, and when we hit play, the snake is no longer there. It's actually inside a different object. And this is done for networking purposes with which objects should have the network identity and so on. So it's basically a workaround, but I think it looks okay, and the hierarchy gets nicely sorted. We then have the two interaction that we have. We have the on collision enter when the player dies. Then we tell all our body parts. We find all our body parts by using our parent. And then we go through them and turn them off. And after we have done that, we turn ourselves off. So the dead snake body will remain. And the other thing is when we enter a trigger, the apples are triggers. So we check if it's an apple. Then we say that we will be increasing our length with 3. Old classic snake does it by 1, but it's more fun when it happens a bit more quickly. We then do the same thing like we did on Death, that we find all the body parts and add some life to them so they stick around a bit longer, so the snake grows longer. And we destroy the apple, of course. So let's look at this body part add lifetime thing next. So that is in the next script, snake body part. And it's basically a timer that runs on update, and every time it runs, it decreases the amount of time we have left remaining with how long time the last frame was. So it's basically a simple countdown, and if it reaches 0, we remove the body part because the one in the end of the tail have lived the longest, and it's going to be the one that disappeared first. This is not a fantastic solution. It's not very efficient. But it's easy and it works, and here's one of the assignment is to remake this with a list, so you reuse body parts rather than always creating new ones and always destroying ones, the last ones. And here we have the function add lifetime that simply increases the lifetime remaining, thus making the object live longer. And the thing that spawns these are the body part spawner that's also on the snake. And here we have what we are spawning. We have a reference to our snake and our old position, because when we have moved to the side, we want to spawn a body part in the old position, so we don't spawn it on ourselves and kill ourselves by colliding with it. So that's basically the idea. And here we're using late update just because otherwise we will have one frame where we have a gap after the snake head before we fill in the next body part. But by using late update, all other movements are done, and we know there's gonna be an empty space, so we fill it directly, and it's updated to the screen on the same frame. And we basically check how long we have moved from our position compared to our old position. If we have moved more than 0.95, we're basically moving 1 unit each time. But if the network for some reason guess how long we have moved and doesn't say that we have moved 1 unit, then we actually have some wiggle room here. I haven't had any issues with it. It can probably be greater or equal. It could probably be equal to 1, but it's not as safe, so why not? We create a new snake part, and we tell that snake part to add some lifetime. So once the snake grows longer, we give each part a bit longer to live. And when we have done all that, we update the old position with the current position so that we have the old position for the next time we are doing this. Yes, so one script remaining to look at. We have snake movement. And it's basically, we have no movement to begin with. And we move in the step update. So this here is 0.1. That means we are doing running this function every 0.1 second, and we are basically taking our position and increasing our direction. And our direction change here depending on what update we on what input we get in the update method. And this is in the update method because we want to get input every frame, not just once every 1/10 of a second. Yes, so and these are the scripts that's in here from the beginning. So I'm gonna show the time here. I'll write about 11 minutes, so I can add a little note. You can jump forward to this point if you're already familiar with the project. Invisible water is probably the best water. Yeah, so let's get starting by adding some multiplayer support, networking. I might not do everything in the natural order here because I'm short on time and I need to get everything done, and I've done this 5 or 6 times the last week, so I kind of like know everything, but I don't do it in the same order I did the first time. So I'll try to be as straightforward as possible, but it might be a bit confusing, some of the parts. Well, first things first, let's get rid of our snake here because we're gonna have the network system spawn our players. Let's create our network system. So a new game object, I'm gonna reset the position. It's an OCD thing, you don't have to. And let's call this network controller. Let's add some components. Let's type network, and we have a lot of stuff. We want the network manager. That's basically a one-off component that you need for the server. And you want the network manager HUD, so you get some buttons that you can easily run things for you. So when we hit play, we now have these buttons here. We have host for creating a server. We have client for joining a server, and we have LAN server only. That's basically a server without any players, a dedicated server. So we're basically gonna use host on one instance of the game and client on all the others. So the clients join the host. And where do we join? We join localhost. That's this computer. You can type in any IP number. If you don't know how to find your IP number or your friend's IP number, just Google it, you will find it. So that's the buttons we get from these two components, or specifically from the manager HUD. In the network manager, we need a player prefab that goes in this field here. And before we can add our snake, we need to add some components to our snake. We're gonna have a network identity, so it can identify it with the networking system, and it's going to be a local player authority so that the local player can control it. Let's also add a network transform. Let's increase the send rate to 20. Since we have very few objects, it's okay to have quite a high send rate. And we don't want to sync the rigid body. We want to sync the transform because we're not moving the rigid body. We're only using that for collision. We are going transform.position, which actually moves our transform. So that's very important. Leaving this at 9 is not good. It has to be at least 10 because we're updating 10 times a second. So you will get more stutter if it's too low. And that is for the snake. We can now go back to the network controller and add the snake to our player prefab here. So that's part done. So now we can test that part out. Let's hit play and hit host, and since we have started a new game and we have auto create player, the game creates a snake for us and we can start moving around. So far so good. The problem is it spawns in the middle and all the players are gonna stack on top of each other, and when they do, they kill each other. So we have to fix that, but let's start with the apples first, actually. So let's select the apple prefab and add a network identity to that one as well. Let's go to the, and this is because we want to be able to spawn the apples over the network and only have the server spawning apples. In network controller, we need to add the apples to spawnable prefabs so that we have told the network system we are allowed to do spawn these prefabs. And to do that, you have to have the identity. Let's move over to the actual spawner that's gonna spawn the apples and add the network identity here as well. And let's hit server only, so that only the server is allowed to spawn apples. And then we need to make some changes to the apple spawner script. We are starting by adding unit engine.networking, and we are inheriting from network behavior. So we get the network, network functionality. So we're not going to do it on start any longer. We are going to do it on public override void on server start. No, on start server. I usually get those mixed up. So on start server, and we need to override the default one. And when we are actually spawning apples, we want to send the spawn apple command over the network. So let's go and type game object new apple. So we saved the newly created apple in our variable and go network server, I think. Can we do dot spawn new apple, like so. So this will send the spawn the newly created instance of the apple through all the clients. And I think that's it for changes in this file. So let's save it, go back to Unity and try it out. So to try out networking on one computer, you need to have at least 2 copies of the game running. So let's go file, build settings, and here we can have the button build and run, and that creates an exe file. So you can also go build and run or control B, which I'm going to be using a lot. So whenever you see the client starting, that's because I hit control B, it builds the game and starts it for me. So I'm gonna hit that. The first time you do it, it's probably gonna ask you to save the exe file. But since I have done this before, it actually just replaces the old exe file. Don't place it in your project folder, place it in a separate folder outside your project, because you don't need to save it. You can always build a new one from the project. It just takes a lot of space. So I hit play, and I now have the game running here, and I have one game running here. So I can press host on this one, and notice the apples here. We have a few good ones to the side here. So when we hit client and join, our snakes collides, but the apples here have the exact same pattern. So you can actually see that this is now synced over the network. If you try this before you change the apple spawner, you will actually see that it doesn't sync, that the apple spawner is different for each player. A few tips: don't forget to save your scene, and don't have too much of a rush pressing this button while the game is building, because if you do that, you lose all the things you haven't saved in your scene. So just a small warning there. Let's see what's next. We need to add some networking to the snake script. So this script is also going to be using networking, and it's going to inherit from networking, network behavior. And we are going to need our start function. And we are going to see. Yeah. Right here above public int length, how long the snake is. This is something that we must send through the network, otherwise your snake gets longer on your screen, but on the other clients and on the server, your snake is not longer because this value has not been sent over the network. So we have to actually tell it to sync the variable with this little flag, sync var, and that means that this is updated in the network. We also have to do the following in the start method. You can't put this in awake, which is a mistake I've done before, because then the networking isn't up and running, and then you get an error. So here we type the following: if not local player, if is not local player, then we are going to get our component that is snake movement, and we are going to disable enables equals false, and this will turn off the movement script for all snakes that isn't a local player, which means that if you don't do this, you can actually control all the snakes from all the computers. So then you have a totally different game. It might be fun, I don't know. You basically have like which plays snake, where everybody gives input all the time. So, okay. Now it says multi-object editing is not supported here. Interesting. I don't know, maybe I have selected multiple things, I don't know. But let's see how far we can go now. So let's build another copy of the game, wait for it to start. Let's start here. Let's play. Let's host it here. So I'm constantly like jumping back and forth. So I'm okay. Let's stop that. I want to host on this one. And before I join here with client, okay, now we get an error. So let's start that one. Before I join here with client, I actually start moving here. I join with the client, and I can now see that this is actually syncing really well over the network. I accidentally went reverse and killed myself, but basically the snake part is now working. And that's really good. I thought it was a few more steps, but I'm gonna keep this video as short, and it's gonna be sub 30 minutes. That's really good, considering this normally is a 2.5 hour lecture, where I intentionally make some of the errors just so people can get a feel for the workflow. Like, okay, I do this, then this happens, and so on, and how do I fix that? But this is more instructional. Just follow along and do the right things. So yeah, let's fix the spawn positions, and that's basically it. So let's go to the yeah, now it's updated. So we have the length, and you can see that it's syncing the length, and it's on a network channel send interval. That's good stuff. Now I'm like, okay, how can I improve this? Send interval 0.1 does not really, yeah, we need that. I was, never mind. Yeah, so let's go in the awake function, and we are going to need a number of players. Actually, let's put this here because it's gonna be a static int, and it's gonna be 0. Static means that it's shared between everything in the class. So if we make a new snake, it's gonna have the exact same number here, and it's not gonna have like this is player 5 and this is player 1. No, we have this many players, and it's over all the classes. So now we can simply check if number of players is larger than 3. That means we have 5 players. We have 0, 1, 2, and 3. That's 4 of them. So if we have player number 4, that's the 5th player, and that is too many. So we're simply gonna go destroy game object and remove that from the game. And before we are doing that, we're actually going, no, we're just destroying that. That's correct. And if not, then we want to select a start position depending on our number. For that, we need an array of positions. So let's create a vector tree, start positions. And we can simply go transform position is equal start positions number of players. So remember, this starts on 0. So we're gonna get the first position from this list, and the next time number of players is gonna be 1. So we get the next position and the next position and the next. And if we are trying again, then we are too many and we destroy. So this list needs to have, this array needs to have 4 elements at least. So let's add them now. So it's you have to press the little arrow here and type 4 to get 4 locations. And the numbers are going to be 80. Oh no, it's 40, 20. Yeah, 420. And we have minus 40 minus 20. And we have minus 40 plus 20, and we have 40 minus 20. And this is basically 4 points located like this. So if I press host, I end up here. And since we're never removing player, if I host again, I'm actually player 1 now. And we can actually see that we have these different locations. And if I try again now, index out of range. I see. We have to actually type return here as well to avoid this error, because he actually continues to run these this line of code before we get the error. But this one will make sure that we are done here anyway. And yeah, that's it. Right on 30 minutes. That's awesome. So the next part is probably going to be next week on Saturday or Sunday. It's going to be a different scene where we have a chat, and you can select your name, you can chat with people, and when you hit join, you enter the game. I think that's the plan. We might actually use that for a bit more. We might actually use that for making sure all the players have joined before we start. That's it for today. I haven't been looking at the stream chat. This is just a quick rundown that I'm going to put on YouTube. Nothing else. But if you have been watching live, thank you for that. If you like this content, please give it a like and subscribe. It will encourage me to do more, if I have the time, of course. But until next time, take care and code more and have fun. Bye bye.